Yan. So, for midterms, we will be discussing the reactions in aqueous solutions. So, you will expect here that we will discuss chemical equations and how to balance equations. Yun yung ating magiging start for midterms. Again, we will be discussing aqueous solutions here. So, for our objectives this morning, you are all expected to, number one, determine the general properties of aqueous solutions, and then discuss the common types of chemical reactions that occur in aqueous solutions, and lastly, identify examples of each chemical reactions. So what will be our topics this morning? We have first, general properties of aqueous solutions. Number two, precipitation reactions. And then we have number three, acid-base reactions. And lastly, we have oxidation reduction reactions. So yun yung magiging topic natin. So brace for chemical reactions and balancing chemical equations. So let's have the first one. I think we madidiscuss natin yung mga chemical reactions natin today. Hindi ko lang siya matatapos given that we have limited time and we don't have synchronous class tomorrow. So I will just be giving you activities tomorrow, class. So let's have the introduction. So pag sinabing solution, it's a mixture. Again, it's a mixture. Sa prelim, we have discussed the classification of matter, and we classify matter as either pure substance or a mixture. Now, we will be concentrating plus sa mixture and specifically sa solution na side. So, si solution is under the homogeneous mixture, meaning you will have a uniform appearance here, a uniform mixture when you say solution. Now, the second one, the second part that you need to know about solution is that it has always two components. Meron talaga siyang dalawang components, and that is what you call the solute and the solvent. Again, matatawag mo lang siyang solution kapag meron siyang dalawang components, and that will be the solute and the solvent. Now, ano ang pinagkaiba ni solute and ni solvent? Si solute, class, is yung present most of the time at smaller amount. So, smaller amount, and most of the time, si solute yung ating dinidissolve. Again, siya yung dinidissolve natin. That is the solute. And then si solvent naman is present at larger amount, and yun yung ginagamit natin to dissolve. That is the solvent. Kung gusto nating i-dissolve si solute, si solvent yung gagamitin natin. So those are the two components of our solution. Now, if we mix them together, since this is a mixture, you will have a uniform appearance. So do not forget, a solution is always under the homogeneous mixture. But when you say solution, we are not just referring to a liquid solution, because a solution can be a gas. Example, the air. Ang air natin, we have discussed that one sa prelim. It is a mixture. It's a mixture of a lot of gases. And since it has a uniform appearance, it's homogeneous. And thus, it can also be called a solution. So air, class, is also a solution. So it's gas. And aside from that, solution can also be solid. So again, solid. Pwede pa rin siyang solid siya, but meron pa rin siyang solute and solvent. So let us give an example of a solution that is solid. We have here the alloy. So I believe you are familiar what is alloy. Marami tayong mga gamit na made up of alloy. When you say alloy kasi, it's a mixture of different metals. Again, when you say alloy, it's a mixture of different metals. So let us be specific with our example sa alloy. Anyone here who knows example sa alloy? Sige daw, if meron may alam dito, sa example ng ating alloy or alloys? Wala. Wala. O natulog na mo din ha. Sige daw, be. Can you
Brass po, ma'am.
Ansa? Sorry?
Bronze po.
Okay, very good. Bronze. I believe you are familiar with bronze, like bronze medal. Like if you get third place in a competition, you will receive a bronze medal. Bronze class is an alloy. It's a mixture. To be specific, it's a homogeneous mixture or a solution. So see, bronze glass is actually a mixture of copper and tin. Again, copper and tin. Those are the components of our bronze. So nakita niyo naman yung color ng bronze medal. It's a mixture of copper and tin. Okay? And then aside from that, we also have the brass. So that's another type of alloy, the brass. This time it's a combination of copper and zinc. Copper and zinc. Yan yung combination ni brass. Okay? So again, those are examples of an alloy. They are solid solutions. They are homogeneous mixtures. Steel is also classified here sa alloy, mga solid solutions natin, cast iron, and even the solder. They are all alloys class. Mixtures sila ng different metals. So, ginagawa nila yan na they mix together different metals, and one reason for that is to avoid and delay rusting. Kasi kung pure metal siya, like iron lang talaga, it's prone to oxidation and it's prone to rusting. Magkakalawang siya kapag pure metal. So again, one of the reason why they mix metal together and they form alloy is that this is to avoid and delay rusting. O kaya yung mga ginagamit example sa sasakyan, marami dyan alloy para hindi agad sa Bisaya pa dili dayon magtaya. So again, that is the reason. And then most of the solutions that we know are actually liquid. So most of our solutions na alam natin are liquid. So example, we have the seawater. So seawater is a solution. It has a uniform appearance, but you cannot just see water there. Though we cannot see the other components with our naked eye, but we know that seawater also contains sodium, asin, to be specific. So it's definitely a solution, homogeneous mixture. So again, aqueous solutions composed of the solute. Most of the time, it's a liquid or a solid. And then you also have here the solvent, the one that we use to dissolve the solute. Now, most of the time, our solvent is water. So we call water as our universal solvent because water can dissolve a lot of types of solute. Marami siyang pwedeng i-dissolve na solute. Kaya siya tinatawag na universal solvent. These are the things that you need to know about our solution. So let's talk first about our solutes since we have two components of solutions. The solutes class, they are classified into two, whether they are electrolytes or non-electrolytes. So again, yung solutes natin, pwedeng tawaging electrolytes, pwede din non-electrolytes. So anyone here who knows the difference between the two, electrolyte or non-electrolyte? Or any idea what electrolyte is? I think you have heard this one, especially when you have diarrhea and then pinapainom kayo ng something to replenish the electrolytes. Ano ba ibig sabihin ng electrolytes, class? Gatorade, yeah. Gatorade is an example of a solution na yung solute niya ay electrolytes. Okay? So tama yan siya na ang Gatorade has electrolytes. Okay? Electrolytes are salts or molecules that ionize completely in solution. So that is class the definition. Yes, tama yan siya, Mariel. That's the definition of the electrolytes. So to differentiate the two, let's discuss them more. We have here electrolytes. These are substances that when you dissolve them in water, they will conduct electricity. Okay, again, when you say electrolytes, they are substances that if you dissolve them in water, they will conduct electricity. So, when you say Gatorade, syempre the electrolytes are being dissolved in water there, pwede yun siya mag-conduct ng electricity. So, bakit siya mag-conduct ng electricity? Kasi sabi nga ni Mariel, they will ionize completely in solution. What do you mean when you say ionize? It means that, tama din itong sinend ni Jella, na they will form ions if you dissolve them in water. We call that ionize. Kapag nilalagay natin sila sa water, magpo-form sila ng ions. And remember, when you say ions, these are atoms with charges. So meron silang charges. And that is the reason why they conduct electricity. Okay? Okay, Shane. And then we have here the non-electrolytes. So ang non-electrolytes naman natin, they do not conduct electricity even if you dissolve them sa water. Yun yung kaibahan ni electrolytes and ni non-electrolytes. So yes, tama yan siya, Mariel, that when you say non-electrolytes, they are compounds that do not ionize at all in a solution. So even if you dissolve them in water, you will not get a charged particle. So kaya hindi siya nagkakonduct ng electricity. So we have here on the screen, you have there an example of an electrolyte. The sodium chloride, or that is commonly known as the table salt or yung asin na ginagamit natin kapag nagluluto tayo. That is sodium chloride. So ang S there, kapag may nakikita kayong S, it means solid. So we all know that asin is really a solid substance. Now, if the table salt is dissolved in water, so you have here the arrow, this means that sodium chloride is mixed with water. It will actually ionize. Again, the sodium chloride will ionize, and when I say mag-ionize siya, meaning it will be separated into its components and then magiging ion sila, meaning meron silang charges. So just like this, si sodium chloride, pag dinisolve natin sa water, actually the sodium and the chloride will be separated and each of them have their charges. So you have their sodium. This is now an aqueous solution, meaning pag may nakalagay na AQ, meaning it's an aqueous solution. The substance is being dissolved in water. So we have sodium positive and chloride negative. And due to the presence of these ions, the asin that is dissolved in water will conduct electricity. So kaya electrolyte siya. So ganun din yung Gatorade class na tinatawag natin, mga sports drinks natin. Meron din yan silang different types of electrolytes. So isa na dyan yung sodium chloride. So again, si Gatorade, meron yan siyang sodium chloride. Kailan ba natin iniinom si Gatorade? So nga yung nag-answer ng Gatorade. When do we drink Gatorade, class? Si Fred Dave. Kailan natin iniinom yan? Fred Dave.
Yung blue, ma'am, para saan, ma'am? GLBM. Usually.
GLB.
Tapos, yung iba sa sports naman to re-energize the body.
So that is what you know about Gatorade. How about the others? Pag na-dehydrate po. Actually, all types of Gatorade can be sports drink. Sports drink talaga sila. Yan naman talaga yung minamarket nila, 'di ba? Na pag sinabing Gatorade, we give them to athletes. So aside from that, though that is off-label, other people would use Gatorade if na-dehydrate, at the same time nag-LBM, there is loose bowel movement, nagda-diarrhea. So bakit ganun? Kasi first, let's talk about the athletes. Since the athletes are doing a lot of physical activities, therefore they sweat a lot. And when we sweat a lot, class, it means that we also eliminate electrolytes inside our body via the sweat. So again, our body contains a lot of electricity. I mean, electrolytes. That is why, class, nagkakandak din ng electricity yung body natin. So inside our body, we have the sodium, the potassium, the magnesium. Those are ions. And that is the reason, again, why we conduct electricity. And kapag ka nagsusweat tayo, na i-incorporate kasi siya sa sweat natin, and ang tendency, makukulangan tayo ng electrolytes sa loob. So kaya yung mga athletes natin, since they sweat a lot, kailangan nila mag-replenish ng electrolyte. So kaya nagiging sports drink yung Gatorade. Okay, I hope that is clear. Now, if you are not an athlete, you should not be drinking Gatorade. Bakit? Kasi hindi naman tayo nagsusweat a lot, and hindi ka naman nagda-diarrhea, 'di ba? Kung hindi ka nagda-diarrhea, you're not doing anything, hindi ka dapat iinom ng Gatorade kasi you will have a lot of electrolytes in your body. So remember, we need electrolytes, but we need to have them balanced inside the body. Kailangan na-balance pa rin, meaning magme-maintain lang tayo ng certain level ng electrolytes inside the body. Kasi kapag sumobra naman, magkakaroon din tayo ng condition. So for example, si potassium, potassium is really needed in our body, especially for muscle contraction, for our heart, and a lot of things pa na ginagamitan ng potassium. So kung nagsusweat tayo, nagda-diarrhea tayo, sa diarrhea kasi ma-incorporate din sa electrolytes when we have diarrhea, ma-incorporate din siya sa stool. So pwede din na magkakaroon tayo ng electrolyte imbalance. So kaya pwede din si Gatorade during diarrhea. Pero kapag hindi ka naman athlete, hindi ka nagda-diarrhea, and then umiinom ka palagi ng Gatorade, you will have a lot of electrolytes, example potassium, magkakaroon ka ng condition na tinatawag na hyperkalemia. And that will be not good sa body natin if tataas yung ating mga electrolytes. So again, wag nyo gawing juice si Gatorade and all the other sports drinks. Aside from Gatorade, meron din tayong ibang sports drinks class na iba lang yung brand. So ano pa ba yun? Mga Pocari Sweat, mga I'm not familiar. I'm not into drinking sports drinks kasi. Ano pa na? Powerade. I think that's what you call it. Powerade. So mga sports drinks natin yan sila. Please do not make it a juice kapag hindi ka naman athlete and hindi ka nagda-diarrhea or wala kang electrolyte imbalance. Extra juice is more of an energy drink. Again, it's more of an energy drink. That's two different things, ha? Kasi si Gatorade and yung mga minention ko kanina, those are sports drinks or those are drinks with electrolytes. While when you say extra juice, lipovitan, Red Bull, we call them energy drink. So bakit sila tinatawag na energy drink? Because they contain caffeine. Again, they contain caffeine, and the reason why we drink those things is to keep us awake, to keep us what do you call that, stimulated the whole day, for example. So yun yung content or component naman ni extra juice. So para ka din lang namang nagkakape kapag uminom tayo. It's just that I think mas marami yung caffeine ng mga energy drinks. So yung mga persons class na sensitive to caffeine, when I say sensitive to caffeine, yung mga nagpapalpitate kapag umiinom ng caffeine, hindi din dapat uminom ng mga energy drinks. So, another thing that you have to take note, aside from hindi nyo dapat gawing juice yung mga sports drinks natin, hindi nyo din dapat ginagawang juice yung mga energy drink. Like extra juice. Basig nalamian mo or lipovitan or Red Bull, nalamian mo, gihimo ninyo juice na sila caffeine. So, a lot of people died because of that. Kasi nagpapalpitate sila and nauuwi into problem sa heart. So, kaya yun yung nagiging reason ng kanilang death. So, again you may also educate other people about this. Kung juice na lang. Wag na yung energy drinks, wag na din yung sports drinks, so that we will not have imbalance inside our body. And hindi din tayo magkaroon ng problem sa ating heart. So I hope I have clarified some misconceptions about that, because I believe a lot of people think na parehas lang yan sila and pwede lang na sila inumon bisag kanus. Okay? So we have also drinks na non-electrolyte. Again, they will not conduct electricity even if dissolved in water. So if a sin class is an electrolyte, and the example naman of our non-electrolyte is this one. Sorry for my handwriting. I'm not using my pen, my, what do you call that? My digital pen. So, hindi ko makontrol. So, we have here the sugar. The table sugar, ginagamit natin. Asukal. Asukal is actually a non-electrolyte. If you dissolve that in water, that will not be the same with the sodium chloride. Okay? Hindi yan siya kagaya ni sodium chloride na mag-ionize, bibigyan kanya ng ions. Si sugar, magdadissolve lang talaga siya sa water, but the molecule, the particle, the chemical substance will be intact. It will remain intact. Hindi yan siya mag-ionize. So, hindi siya mag-kakandak ng electricity. So, again, tinatawag natin yung non-electrolyte. So, to give more examples of this one, we have electrolytes here, but the electrolytes are further classified into strong and weak. Again, yung mga electrolytes natin can be strong electrolytes or they can also be weak electrolytes. Now, for the strong electrolytes, I'm not saying all, but most of our strong electrolytes are strong acids, strong bases, and yung mga salts natin. Again, yung mga strong electrolytes natin mostly are strong acids, strong bases, and our salts. So we have here the hydrochloric acid, the nitric acid. We also have here the perchloric acid, and then the H2SO4, the sulfuric acid. Those are strong acids class, so they are definitely strong electrolytes. And then we have strong bases here, sodium hydroxide and barium hydroxide. And then itong mga ionic compounds, ito yung sinasabi ko na salts. They are all strong electrolytes. They are called strong electrolytes because they completely ionize in water. So the term there na bantayan ninyo is the word completely. There will be complete ionization, meaning lahat ng components niya dyan ay magiging ions, magkakaroon ng charges. Example, hydrochloric acid, si HCl. Kapag nilagay natin siya sa water, HCl will be separated into its components, hydrogen and chloride. And those two will have charges. So complete ang ionization. Kaya siya tinatawag na strong electrolytes. Now itong nasa gitna, we call them weak electrolytes. Bakit weak? Kasi they will not completely ionize in water. So to clarify that, itong mga substances na ito, mag-a-ionize pa rin. Magkakaroon pa rin ng ion, especially if we dissolve them sa water. Pero hindi kasi complete yung ionization nila. So merong maiiwan class na particle na though meron siyang charge, pero I mean hindi siya lahat. So para ma-picture out ninyo kung anong mangyayari when it comes to the weak electrolytes, let's have the example there. CH3COOH. CH3COOH. This is what we call the acetic acid. And ito yung component ng ating vinegar class. The acid component of our vinegar is the CH3COOH or our acetic acid. If we place this sa water, this will give the acetate ion, CH3COO negative plus a hydrogen ion. So as you can see, you have there the ions. So nag-ionize pa rin siya, pero hindi complete. So look at the acetate, CH3COOH. You have a lot of components there na hindi naman nag-ionize. So hindi kagaya sa part ni HCl na lahat talaga H and then Cl. So there is complete ionization. That's the difference between a strong electrolyte and a weak electrolyte. Hindi lang complete, pero nag-a-ionize pa rin. Now, in terms sa pag-conduct nila ng electricity, syempre weak din ang pag-conduct nito ng electricity. So by the way, water itself is an electrolyte. It's a weak electrolyte. So water will definitely conduct electricity. Pero dito lang siya has a weak electrolyte. Ayan. And then may nakalagay dito H2SO4. Bakit may asterisk yan siya dyan? Kasi si sulfuric acid, meron yan siyang dalawang hydrogen. Pero kapag nilagay mo siya sa water, isang hydrogen lang yung mag-a-ionize. Okay? So only one of the hydrogen ions is totally ionized. Kaya siya may ganyan. Pero definitely, it's still a strong electrolyte. Strong electrolyte pa rin si sulfuric acid. Now, on the right side, you have their examples of our non-electrolytes. If we dissolve them in water class, they will not ionize, therefore they will not conduct electricity. And ang mapapansin natin for our non-electrolytes is that they are organic substances. Paano malaman kung organic? Paano nga natin malaman na organic yung ating substance?
Carbon containing po.
Okay, very good. Carbon containing. Our substances here contain carbon. So like urea, you have carbon there for urea. Methanol, that is one type of an alcohol, so you have carbon. Ethanol, that's another type of alcohol na pinakaginagamit natin as disinfectant and antiseptic. So C2H5OH, that's the chemical formula for ethanol. Glucose. Glucose is a type of sugar. This is actually the physiological sugar. Pag sinabing physiological sugar, yan yung nakikita natin inside our body. Yan yung tinatawag na nating blood sugar or blood glucose. Other name for glucose is dextrose. So kapag na-hospital ka, pwede kang bigyan ng replenishment ng dextrose. So that is still glucose, our physiological sugar. And when you dissolve that in water, it will not ionize, so it will not conduct electricity. And sucrose, this is what we call the table sugar. So this was my example a while ago. Our asukal, if you dissolve that in water, it will not ionize. So non-electrolyte siya. So yan yung kanilang mga chemical formula. Sucrose is C12H22O11, while glucose is C6H12O6. So as you can see, they all have carbons in their chemical formula, thus they are organic. So again, most of our non-electrolytes are organic substances. They contain carbon in their formula or in their structure. So the human body class actually contains a lot of strong and weak electrolytes. So aside from the non-electrolytes na makikita natin inside, marami din tayo class strong and weak electrolytes. So definitely our body will conduct electricity. Magkakandak talaga ng electricity kasi marami tayong electrolytes inside. Questions so far? Alin dito yung hindi naintindihan? Simula sa start, sa solution, and sa solute. Yung solutes natin can be electrolytes or non-electrolytes. Or questions? Do you have questions or clarifications? Wala. So let us continue. So let's talk about the water. Water class is our universal solvent. It can dissolve a lot, various types of solute. So very effective siya as solvent, especially for ionic compounds. Pag sinabing ionic compounds, we are done discussing that sa prelim. Di ba pag ionic compounds, these are compounds that contain cations and anions. Kagaya ni sodium chloride. Sodium is positively charged. So, meron siyang cation. And then si chloride is negatively charged. So, it's an anion. So, altogether, we call it an ionic compound. So, si water naman is very effective when it comes to dissolving the ionic compound. So, bakit siya naging effective? Kasi, since water is a compound, so it's actually electrically neutral. Wala kang nakikitang charge dyan. Pero if you look at it closely, since meron siyang hydrogen, which is positively charged, and meron siyang oxygen na negatively charged naman, so meron siyang dalawang poles, pwede siyang positive, may poles na negative. So definitely, since opposite attracts, pag lalagyan mo siya ng ionic compounds, magkakaroon ngayon ng interaction between them. So sa ionic compounds and sa water. So that is the reason why this is very effective when it comes to dissolving ionic compounds, or we call it a polar solvent. So pwede din siya ma-dissolve ng mga polar na compounds. So most of our polar compounds are ionic compounds. Merong mga charges. Okay? Now, another thing that you have to take note, acids and bases are also electrolytes. Actually, na-mention ko siya kanina na most of our strong electrolytes are also strong acids and strong bases. Kagaya ng hydrochloric acid and nitric acid. They are both strong acids and they are also considered as strong electrolytes. So what is the reason? What is the reason why we also call them strong electrolytes? Kasi itong mga acids na ito will ionize completely. The word is completely in water. Mag-ionize sila completely in water. So for example, hydrochloric acid, if we place that in water, you will get there a hydrogen ion and you will also get the chloride ion. So complete yung ionization in water. It's a strong acid or a strong electrolyte. So on the other hand, let's differentiate it with an acid that is considered a weak electrolyte or a weak acid. We have here on the screen CH3COOH. Again, we call that the acetic acid. To differentiate the two, most of our strong acids are inorganic acids, meaning they don't contain carbon in their structure. And most of our weak acids are organic acids, meaning they do contain carbon in their structure, just like the acetic acid. Acetic acid is CH3COOH, so organic acid siya. And kapag nilagay natin si acetic acid sa water, kagaya ng illustration sa screen, magiging acetate ion siya. We call this acetate ion CH3COO negative, and you also have H+. So walang complete ionization. Again, nag-ionize pero hindi complete. Kaya acetic acid is a weak acid or a weak electrolyte. Okay? So, please be reminded, pag sinabing ionization, we are referring into the separation of acids and bases or even our ionic compounds into ions. Kapag nag-separate na ang ating compound into substances with charges, we call it ionization. And meron tayong tinatawag na reversible reaction. Pag sinabing reversible reaction, these are the reaction that can occur in both directions. So kapag nakakita kayo class ng chemical equation na ang arrow na ginagamit is ganito, that is what you call the reversible reaction. Okay? This one, this arrow. We call that reversible reaction, meaning this one, this part here is called the reactant. Let me write it legibly. This part here in the equation is what you call the reactant or reactants kapag marami sila. And on this side, we have here the product or the products. So kapag reversible reaction, the reactant can combine or separate to form the products. But pwede din natin siyang i-reverse, meaning the products can also interact with each other. They can also combine to form the original reactant. So pwedeng pa ganyan, pwede ding pabalik. Kaya reversible reaction siya. So most of our ionic na mga equations are reversible. So the products can combine again and form the original reactant. So any question about this before tayo mag-continue? Wala. So let's move on. Wait lang ha. I want to have a blank slide here because before we'll talk about precipitation, I will discuss first the different types of chemical reaction. Hindi kasi siya nakasali dito sa slide. So we have the first one. We have here types of chemical reaction. Chemical reactions. So number one, we have the combination reaction, or this is what we call the synthesis. Synthesis. So anong ibig sabihin kapag combination, reaction, or synthesis? This is where our molecules or our atoms combine to form a compound. So let me give you an example. So combination or synthesis reaction, you have one type of element combining with another element to form a larger molecule, and that is what we call a compound. So ganito yung general equation natin kapag combination or synthesis. So to have a specific example, we have here the magnesium. Again, we have here the magnesium. This is one element. Combining with another element, example, you have the oxygen. So si oxygen naman is a diatomic molecule, right? Nung prelim, diniscuss natin ito, diatomic molecule, the Birchnow or the Birchnow. These are elements na kapag hindi sila nakakombine with other elements, always silang dalawang atoms. Kaya meron talagang subscript dyan na 2. So magnesium will combine with oxygen to form a compound. That is what we call the magnesium oxide. Again, the magnesium oxide. So this is a combination or synthesis reaction because we are combining 2 elements here to form a compound. Okay? But question, is this a balanced equation? Anyone? Is this a balanced equation? Magnesium plus oxygen equals magnesium oxide. So this is not a balanced equation because you have 2 oxygen sa reactant na side and you only have 1 oxygen in the product na side. So basig mangutana mo, ma'am, wala lagi na nimo gikopya ang 2. Nganong dili man siya MgO2? Ngano man ni siya? Kasi remember, di ba naghimo na taog chemical formula sa prelim? Pag i-combine na nimo silang duha, magnesium, tapos si oxygen, di ba the final chemical formula will be dependent sa ilahang charges. Di ba si magnesium kay positive 2, tapos si oxygen kay negative 2. I hope wala mo nag-pass is pass na paghuman sa prelim exam gikalimtan na ninyo tanan kay kailangan nato to sa atuang succeeding na mga lessons. So, di ba pag compound gina-add nato ni ang positive ug negative charge, this is equal to 0. And di ba pag equal to 0, we are not doing the crisscross. Instead, we will just combine the symbols of the 2. So you have here MgO. Kaya hindi ko siya kinopy yung subscript ni oxygen. Hindi siya dapat MgO2. This is wrong. Okay? So ang ginagawa, class, nagbabalance na lang tayo ng equation. Kailangan balance kasi kung ilang atoms ang nasa reactant, ganun din dapat ang nasa product. So yun yung tinatawag natin na law of conservation of mass, that matter is not created nor destroyed. Meaning you have magnesium and oxygen and reactant, you can also see that sa product na side. But we have to make sure na the same pa rin yung mass nila. Kaya nagbabalance tayo ng equation. How do you balance an equation, class? Ano yung nakagawian nyo na way sa pag-balance ng equation? Are you doing like this? Ako kasi, pag nagbabalance ako ng equation, I'm writing all the components like magnesium and oxygen. And anong ginagawa ko? Sinusulat ko first, sa hindi pa balance na equation, sinusulat ko kung ilang atoms ang nandyan. So like this one, sa reactant na side, I only have 1 magnesium. On the product na side, I also have 1 magnesium. But for the oxygen, sa reactant na side, I have 2. But on the product na side, I only have 1. So this one is definitely not balanced. So in balancing equation, ang chine-change lang natin, class, is yung coefficient. So si coefficient is the number written beside the chemical formula. So beside ha, kasi itong 2 na ito, ang tawag natin dyan, subscript. And subscript, class, represent the number of atoms for each element na present. So kapag sinabing O2, meron ka dyang 2 atoms ni oxygen. Pero si coefficient naman, nilalagay siya sa tabi ng ating molecule. Example dito sa tabi niya. That is what you call a coefficient. And yan yung change natin when we are balancing equation. Now, ang nire-represent naman ni coefficient is the number of molecules na meron tayo sa compound, meaning sa buong compound talaga, hindi lang para sa element A, kundi para sa dalawa talaga, sa buong compound. So when I balance this one, I have to make sure that the other side will also have 2 oxygen. So I can place 2 here. Again, I can place 2 here, but this 2 represents na meron akong dalawang oxygen, pero since kasama ni oxygen si magnesium, so si magnesium will, si magnesium will also have 2. Wait, let me erase this one. So this will become 2 here. So oxygen has been balanced, but magnesium is not balanced now. So what will I do? I will also place 2 here. Hindi ko siya nilalagay as subscript ha. Ilalagay natin siya as coefficient. So this will become 2 also. So in this case, this is already a balanced equation. So this one is the correct one. 2 magnesium will react with oxygen and it will give you 2 molecules of magnesium oxide. Balanced equation, but when you say type of chemical reaction, it's combination or synthesis. Gumagawa tayo ng compound. Any question, class, about the combination or the synthesis? Wala? So let's move on sa number 2. Let's have the second type of chemical reaction. This is what you call the decomposition. Decomposition reaction. Again, decomposition reaction. This is the complete opposite of our combination reaction because this is where the molecules or the compound separate. So kabaliktaran siya. If you have a compound AB, pag sinabing decomposition reaction, it will decompose, maghihiwalay ang components niya. So you have A plus B. Kaya sinabi ko na this is the complete opposite of the synthesis or the combination reaction. Okay? So, ano nangyari dito? Si compound nag-separate into its component. So, kabaliktaran siya. Kung magbibigay tayo ng example, I'll still have the magnesium oxide. Kapag dinicompose natin si magnesium oxide, we will get the magnesium and also the oxygen. So always remember, oxygen belongs to the diatomic molecules. Na pag sinabing diatomic molecules, kapag hindi na sila nakakombine with other types of elements, always silang dalawang molecules. So Birchnoff yan siya. Anong ibig sabihin ng Birchnoff? B is bromine. So si bromine, kapag hindi siya nakakombine with other elements, always yan siya may subscript na 2. The same thing with iodine. C is for chlorine. H is hydrogen. N is nitrogen. O is oxygen. And lastly, F is fluorine. So kung nakikita ninyo here, pag pinaghiwalay natin si magnesium and si oxygen, always yan siya may 2 for oxygen. Now this one is not also a balanced equation. So if we balance this, Now, you have magnesium and oxygen. For the unbalanced equation, you have 1 magnesium on the reactant side, 1 magnesium on the product side, 1 oxygen, and 2 oxygen. So, hindi siya balanced. Kaya lalagyan natin siya ng coefficient. So, lalagyan ko dito ng 2 para si oxygen ay magiging 2. Pero since kasama niya si magnesium, magnesium will also become 2. Thus, I will also place a coefficient here para magnesium on the product side will also become 2. So, this is now a balanced equation. Kapag ka naghiwalay ang dalawang molecules ng magnesium oxide, it will produce 2 molecules of magnesium and also oxygen. So ito yung tinatawag natin na decomposition reaction. Okay? Questions? Questions so far? Alin dito ang hindi naintindihan? Wala, natulog na mo? Sorry. Wala pangutana. So mag-move on ta. Mag-move on ta sa number 3. Let me change my pen. Let's have number 3. We call this the single replacement reaction. Single replacement reaction. Okay? This one is the third type of reaction. Ano yung ibig sabihin kapag single replacement? Ganito yung illustration niya. If you have a compound, tapos pinag-react mo siya with an element. Again, you have here a compound. Pinag-react natin sa isang element. Tinatawag siyang single replacement kasi itong element na ito ay i-replace ang isang element sa compound. Pero always remember that if this is positively charged, yung papalitan niya dito sa compound ay yung positively charged din. Kaya ang magiging result nito ay CB plus A. So ganun yung single replacement class. Again, please remember, pag single replacement, you have there a compound, tapos ipapareact natin siya with an element. And then ang mangyayari, ang element na yan ay i-replace niya ang isang element doon sa original compound mo. Kaya naging AB plus C equals CB plus A. Yan yung tinatawag na single replacement. Pero si single replacement ay hindi basta-bastang nangyayari. Kasi meron tayong tinatawag na activity series of metal. Again, meron tayong tinatawag na activity series of metal. Na ngayon, di ba meron kayong index card para sa mga polyatomic ions. I want you to add the activity series of metal class in your index cards. So, mahahanap natin siya sa Google. Let me open a Google here. Open ko browser because I will let you see the activity series of metals. Sorry. I hope you can see it in your screen, this part here. This part here, this is what you call the activity series of metal. Nakapasunod na siya class, gikan kay potassium, padulong kay platinum, And mao ni siya ato ang listahan sa reactivity of our metals. And ito yung babasehan natin sa single replacement. Okay? So, kung nakikita ninyo, si potassium yung nasa pinakataas. And that means that potassium is the most reactive among them. Siya ang pinaka-reactive, meaning siya ang pinaka-strong na metal na talagang magre-react siya with other substances or with other compounds. And then we have sodium, lithium, and pababa na yan siya class. Anong ibig sabihin yan? Kapag ka sa single replacement, hindi pwedeng ma-replace ng element na nasa baba ang element na nasa taas. Okay? So always remember na before tayo magkaroon ng single replacement, dapat ang ipapalit mo na metal ay mas reactive kaysa sa nasa original na substance natin. So para mas maintindihan nyo, balikan natin yung ating slide. Ay, wait. I'll have to paste. I'll have to paste here the activity series of metal para mas ma-picture out niya siya. Lang, ha? Pero again, isalin nyo ito class sa inyong index card. Kasi medyo marami and kapag wala kayong index card, baka malito kayo. Kapag pinagawa ko na kayo ng reaction. So ganito, para mas maintindihan siya. Time is it? It's 8:42. So again, we are sa number 3, single replacement. So ginagamit natin si activity series of metal for single replacement. It means you have there a compound reacting with an element and then that element will replace the original element sa compound mo and made-displace yung element na yon. Pero ang tandaan natin, dapat ang papalit na element ay mas reactive. So let me give you an example. You have here a compound, ang asin, sodium chloride. Tapos ipapareact natin siya kay potassium. Ayan. Si sodium chloride, ipapareact natin kay potassium. Now, si potassium is not a diatomic molecule ha, so walang 2 dyan. Now, kung titingnan natin ang activity series of metal, number 1 si potassium, number 2 si sodium. Ang ibig sabihin yan, si potassium ay mas reactive kaysa kay sodium. And for single replacement, that is possible. Kapag ang element na ipapalit natin ay mas reactive, talagang what do you call that? Magte-take place yung reaction. Okay? This one is a possible reaction and it means that kaya ni potassium i-replace si sodium. So ang product nito ay KCl plus Na. Magpapalit sila ng pwesto. Again, sodium chloride plus potassium, this is a possible reaction because potassium is more reactive than sodium. Thus, mangyayari yung replacement, you will have now the potassium chloride plus sodium. Okay? Questions about this one? Any question about this part? Now, ang pangutana, is this a balanced equation? Anyone? Again?
Balance po.
Okay, this one is a balanced equation. So if you will look at it, we have 1 sodium sa reactant. We also have 1 sodium sa product. 1 chlorine po sa product and 1 potassium for both sides of the equation. So this is a balanced equation already. No need to balance. Okay? Again, this is a possible equation. But let me give you an example of an impossible single replacement equation. Kapag baliktarin natin class, you have here the KCl, potassium chloride, plus the sodium. Again, potassium chloride plus sodium. The answer here is NR. And anong ibig sabihin ng NR? No reaction. So kahit pa ipaghalo natin si sodium chloride at si potassium chloride at si sodium, walang reaction na mangyayari. And what is the reason for this? The reason for this is that sodium is what? Less reactive compared to potassium. So, kasi less reactive siya class, hindi niya talaga matatalo si potassium dyan. Kaya walang replacement na mangyayari. That is the reason why I need you to write also in your index card the activity series of metal kasi pwedeng no reaction yung answer. Magiging no reaction yan siya kapag ang element na supposedly ipapalit mo ay less reactive. So pag less reactive siya, hindi mo talaga yan matatalo. Okay? Questions? Wala? So kung uyab-uyab pa ni class, pag ang iilis sa imuha kay let me just use this term for the sake of the illustration. Kung mas pangit ang iilis sa imuha class, di jud ka mapilde. So no reaction. Mo na siya ang ginatawag og single replacement. Ha? That's just for the sake of comparison ha, pero I'm not saying na ambot depende na sa inyo ha kung sa'yo pasabot. But anyway, again, kung sa uyab-uyab pa na kung mas pangit class ang iilis sa imuha, di jud ka mapildi. No reaction yun na siya. Pero ang atong problema class, kung ang iilis sa inyo kay kung iilis sa inyo mas gwapa nga pildig yun ka. So there will be a replacement there. Mapildig yun ka. Mag solo flight na lang ka. Mo na siya ang single replacement. So I hope nasundan ninyo to. I hope nasundan ninyo ang single replacement. So we will be considering the activity series of metal. Okay? Questions about the single replacement? Ang inyong tandaan ha, dapat mas strong or stronger. Dapat more reactive ang iilis na element before magkaroon og reaction. Pag ang iilis na element is less reactive, ang inyong i-answer ana kay NR, meaning no reaction. Okay? Questions? Wait lang, let me have another slide. I have to complete before we'll end. I'll be completing all types of reaction. And the last type of reaction is, we have number 4, the double displacement. We call it double displacement or double replacement. Parehas lang yan sila. Double displacement or double replacement. Or sometimes we call this a metathesis reaction. Okay? Double displacement, double replacement, or metathesis reaction. And what do you call, how do you describe this type of reaction? Mo ni siya class ang ginatawag nato og exchange partners. Again, double displacement reaction is what we call the exchange partners. So for example, you have a compound here and pinag-react natin siya with another compound. Ang mangyayari, mag-e-exchange sila ng partners. Pero pag mag-exchange og partners class, always remember na opposite attracts ha. So positive, negative, positive, negative. Ang mangyayari pag nag-exchange sila, ang positive dito, magpa-partner with the negative with the first one. And ang positive sa first na compound will partner with the negative sa second na compound. So this will be the product. Again, opposite attracts, always yan siya positive and negative. And always class na uuna sinusulat si positive kesa kay negative. So let me give you an example. You have here the NaCl plus, let me use a simple one first. And then we have the potassium fluoride. Again, we have here the sodium chloride plus the potassium fluoride. Sa double displacement class, hindi natin kailangan si activity series of metal. Again, hindi natin kailangan dito si activity series of metal. Mag-e-exchange partners lang talaga tayo. So pag let me delete this one. So pag mag-exchange partners tayo, ang mangyayari, ang una nating gagawin is to identify first the cation and the anion. Kung sino yung positively charged and sino yung negatively charged. So, di ba si sodium is positive 1? Look at your periodic tables. Si chloride is negative 1. Si potassium is positive 1. It's located right below sodium. And then fluorine is negative 1. So, anong sabi ko kanina? Ang positively charged dito ay magpa-partner sa negatively charged sa second compound. So you will have now the NaF plus yung positively charged dito ay magpa-partner kay negatively charged sa kabila. So you will have the KCl. So this is what you call a double displacement or double replacement reaction. There will be exchange partners. Okay? So, ang single replacement kagay na ngunta, kung atoa siyang i-compare, kung mag-uyab-uyab mo class, mapildi jugag mailisan ka. Pag stronger or mas guwapa sa imo yung iilis. Pero sa double displacement, ano ni siya? Pero nato ni siya makita sa mga artista, exchange partners. Murag nagdula og open the basket og change the basket. Magsigilan sila exchange partners. Muna siya ang double displacement class. Kung chemical reaction na class, exchange partners, kina siya ang tawag na to na double displacement. Okay? Nag-ilis sila og partners. Pero the same lang ha, kasi we have the law of conservation of mass. So pag abot sa product, kung unsa na mga elements inyong nakita sa original na reactants, mo gihapon inyong makitaan sa products. Exchange lang sila og partners. Ang inyong halang tandaan, wala ta nagagamit og activity series of metal dinhi. Instead, we will just look at the charges kasi always man yun siya opposite attracts. So, mag-exchange partners sila. Okay? So, yan muna. Diyan muna yung discussion ko. We will continue next meeting. I'll just give you an activity tomorrow. Dili siya pwede KCl plus NaF. Pwede siya. Pwede ra kayo siya. Example, ang sinulat natin, di ba? NaCl plus Kf, tapos nauna mong sinulat si KCl kesa sa NaF. This is always possible also. This is also correct. It doesn't matter kung ano yung una mong isusulat as long as tama yung products mo dyan. Okay? That is the good thing about double displacement. Okay? Anything else? Anything else, class? I'll have more of this. I'll have more of this next week. Kasi si double displacement, hindi lang yan siya basta-bastang nag-exchange partners. Kailangan pa natin i-make sure na tama yung chemical formula ng products natin. But I hope na naintindihan nyo yung kanyang concept, kung anong nangyayari sa type of chemical reaction na ito. Okay? Questions so far? It's 8:56. I need to end here so that you will not be late in your next class. Wala na bang clarification? Wala?